Welcome back to Strength of Material Lectures by Still Thinking, and today we are going to solve a problem on principal stresses and strains. Now the problem is on your screen. It is saying a square concrete column is 4 inch by 4 inch in cross section and is subjected to a compressive load of P. Okay, this is the column and the cross section dimensions are 4 inch and 4 inch, and a load of P is acting. Now the condition is if the compressive stress cannot exceed 4000 psi. Okay, now it is saying the conditions are sigma c means compressive stress, it cannot be greater than 4000 psi, and the shear stress cannot exceed 1500. And let me denote the shear stress with tau. It cannot exceed 1500 psi. Now the maximum allowable load P is most nearly, you have to choose the value of P. Okay, this load, you have to choose the value of this load such that these two conditions satisfy. That's all. Okay, we have to choose P such that these conditions are satisfied, right? Now the compressive stress. Now let first of all let me choose axis. Let me consider this to be x axis. Okay, and let me consider this to be y axis. All right, now as you can see here, there is only one load, that is compressive load acting on this cross section, right? It means this cross section, as there is only one load, compressive load acting on this cross section, it means this cross section is a principal plane, right? Principal plane. Why it is principal plane? Principal plane is something in which there is only normal stress or compressive, okay, on which only normal stress acts. Okay, only this. That means if there is no shear stress acting and only normal stress, now this P is acting, this is compressive. Okay, the normal stress can be compressive or tensile, whatever. If there is only one stress, normal stress acting, then that is a principal plane. Okay, now we have to see, now the conditions are if the compressive stress cannot exceed 4000, that means we can choose compressive stress sigma c equal to 4000 psi. Okay, 4000 psi. Now the load is P. What is the value of compressive stress? Sigma C is equal to load divided by cross sectional area, right? A. So it is P divided by, now it is 4 inch by 4 inch, right? So the area of this cross section is 4 multiplied by 4, which is 16, right? So the compressive stress is P divided by 16, right? And the another condition is maximum shear stress cannot exceed 1500. Now on this plane, let me draw it here. Okay, let me say this is P, this is P. Now on this is the principal plane, right? I have already told you there is no shear stress acting. Now shear stress is 0 on this plane, but how can we satisfy this condition? The shear stress cannot exceed, okay, the maximum shear stress tau max cannot exceed 1500. That means in the whole column there will be some planes. Yes, this is a principal plane with 0 shear stress, but there will be some plane, for example like this. Okay, there will be some plane, okay, for example, which is inclined at some angle theta. Okay, for example we can say right like this. Okay, for example this is the plane. Okay, this is the plane on which there will be shear stress. We call them as oblique planes, okay, which are inclined by angle theta. If I show this face like this, okay, this one is this plane, right? I'm showing this with like this. Okay, now there will be some plane, let the inclination be some angle theta, there will be some shear stress tau max. Okay, now if we want to find the maximum shear stress on an oblique plane, for example, this is y-axis, right? It means this is sigma y, and this is x-axis. It means here will be some stress of sigma x. Okay, now on this plane, okay, there will be tau max is equal to whole under root of sigma x minus sigma y divided by 2 whole square plus tau xy square, right? This is the maximum shear stress on an oblique plane. Okay, why I'm writing this? Why? Because I know at this plane there will be no shear stress. So how I am going to satisfy this? Of course, this is a column. Even if this is a principal plane, so what, there will be some plane, okay, anywhere. Of course there are multiple planes. Okay, we call them as oblique planes because they are inclined by angle theta to the horizontal, where there is a maximum stress. Okay, this is tau max. Okay, and it is given by tau max is equal to sigma x minus sigma y by 2 plus tau xy square. Okay, at this stress should not exceed 1500. Okay, this is how we are going to satisfy the equation. Now tau max is sigma x minus sigma y divided by 2 whole square. Now look at this. Okay, as we know, there is only one stress acting, right? This is y axis, right? And this is x axis. There is only one stress or load acting only in the y direction. There is no stress acting in x direction. Okay, so this is 0, right? So I can erase this one. Okay, now sigma y is the stress in the y direction. Okay, sigma y is what? As we know, sigma y is in this direction, but p is opposite, right? So sigma y is negative of this. Okay, sigma y is negative of compressive stress. Do you understand? Because sigma y is up direction, the compressive load is in the downward direction. It means sigma c, the compressive stress will be in downward direction. All right, so they are opposite. So sigma y is minus sigma c, which is negative of p by 4, which is negative of p upon 16. Okay, so here we can put sigma y as negative of p upon 16. Okay, again here is a 0, the negative will be positive anyways. Now again we know this tau xy is something like this. Okay, this is tau xy. Again here is no tau xy acting. Okay, there is only one compressive load acting. It means this tau xy is 0 too, so I can erase this, right? So we are left with only this. Okay, now I can put here sigma y minus p upon 16, minus p upon 16. Okay, now 16 will go into this denominator, so tau max will be, okay, under root of p divided by 2 multiplied by 16, right? Now 2 multiplied by 16 is 32, so I can write 32, right, whole square, right? Now this square and the root will cancel out. Okay, the square root and the square will cancel out, so we are left with tau max is equal to p divided by 32. Now tau max equal to p upon 32. Now what is the condition? Tau max, the maximum shear stress, it cannot exceed 1500. Okay, so I can just write it can be up to 1500 psi, right? So what is going to be the value of p? It is going to be 32 multiplied by 1500, right? We get this p from shear stress condition, right? This, let me erase this first. Now how much is it? 32 multiplied by 1500. How much is it? It is 48000. Okay, if you use the calculator. So this condition, right, shear stress condition gave us what? P equal to 48000. What is going to be the value of p using this condition? Now here we can see the sigma y is p upon 16, right? Now the maximum cannot exceed 4000, right? So it is from here I can write 4000, right? 4000. So 4000 is going to be p upon 16. So p is 4000 multiplied by 16. Okay, how much is it? It is 64 0 0 0. Okay, now this condition is giving me the P of 64000, right? Now we are to find the maximum allowable load P. Okay, but we get two values of P. One P is 64000 and another P is 48000. We have to choose the load such that this column does not fail in shear and this column does not fail in compression. Okay, so for example, if I choose the value of P to be 64000, then what is going to happen? If I choose, let me say, P is 64000, then what will happen? Now 64000 is more than 4800, right? It means this column will fail by shear. Why? This will exceed 4800, right? Then this column will fail in the shear, right? So we cannot choose this one. Can we choose this? Let me choose P equal to 48000. If I choose the load to be 48000, then it is less than the compression, right? The load which is given from the compression. It means this column will not fail in compression. Okay, so we will satisfy this if we choose this. Also, if we choose P to be 4800, because it's under the safe limit, right? Because that's the maximum value, we can choose only up to this. Okay, when we choose this, so this column will be safe in shear 2, right? So when we choose P to be 48000, we will be safe in shear and we will be safe in compression too. Okay, so what is the right answer? Right answer is option D. Okay, I hope you understand. Thank you for watching. If you have any doubts, please comment, and also if you need the PDF of this video lecture, it is in the description. You can download the PDF of this class in the description. Okay, and I think that's it for today. See you in the next class. Thank you.